All right, so we're back for part 2 of AP Calculus. This was the pretest number 2. Let's see the title there so you can see. Yep, there we are in pretest 2. We left off on problem number 14. I said that this was going to be quotient rule. The rationale, once again, just in case you missed that, was we have division happening with a variable on the top and the bottom. There's a house on the top and a house on the bottom. So we're forced to use quotient rule. Once again, quotient rule is low d high minus high d low all over low or low squared. So in this case, let's fill this in. For low, we've got x squared plus 1. And that's going to be multiplied by, so I don't need a dot anymore, it's just parentheses, the derivative of high. The derivative of the top is 1. And then subtract high is x plus 3. And that's going to be multiplied by the derivative of the low. So the derivative of x squared plus 1 is 2x. This is all going to be divided by low. So this is going to be x squared plus 1, and that quantity squared. So we've finished with the calculus, the AP calculus quotient rule. I was trying to stall there thinking of this name. Quotient rule, and we're ready to plug in. As soon as you can plug in -2, do it as soon as possible. So I can do it right now to all of these x's. Let's go ahead and do that. So when I do that, I'm going to get -2 quantity. Let me change the color here. It's going to be -2 quantity squared plus 1. And that's going to be all times 1, which I'm not going to write because times 1 is ignoring it. We'll ignore it, right? There's going to be -2 plus 3 times 2x, which is going to be 2 times -2. And this is all going to be divided by, it's going to be -2 quantity squared plus 1, and that whole quantity squared again. All right, let's see if we can simplify this thing. I've got -2 squared. Whenever you have a negative squared, it's going to turn into a positive, so this is positive 4. This is going to turn into a positive 1. This is going to turn into a -4. This is going to turn into a positive 4. So if I simplify this, this is going to be 4 plus 1, which is going to be 5. Minus, what else we got? We got 1 times all of this stuff. So 1 times -4 is -4. So -4. Looks like we have a double negative happening. And down here we have to be careful. 4 plus 1 is the 5, and 5 squared is 25. So when I always do this rule, when negatives kiss, they become positive. This is going to be 9 over 25. 9 over 25 looks like the correct answer here is E. In number 15, we have a review question, the limit to infinity. Whenever you do limit to infinity, this is going to be your top-bottom rules. Which is the bigger, the top or the bottom? I think this question was exactly pulled from Unit 1. Let's go ahead and see here. So you're too small, you're too small, you're too small, you're too small. So what I have is a positive 2x squared and a negative 3x squared. A lot of people will forget that negative, and they'll accidentally get a positive answer, although I don't see how you could get that still for a multiple choice. Top-bottom rules, we look at the power, Powers are the same. So whenever you have top, bottom, be the same, that's going to be a magic fraction. This is equal to a magic fraction. My handwriting is atrocious right now. Magic fraction being you essentially ignore the x squared, and it's going to be this fraction 2 over -3 or a negative 2/3. Sorry, 8. Number 16, a very pixelated number 16, isn't it? The function is continuous between that interval. Okay, so every time that you see the word continuous, you automatically underline that and say, okay, I've unlocked intermediate value theorem. Every time that you see differentiable, you underline that and say, I've unlocked mean value theorem and technically intermediate value theorem, because if you're differentiable, you're also continuous. And does it say closed anywhere? It's continuous on this closed interval, so this closed symbol means that we've unlocked extreme value theorem. And it tells us this value. So as soon as you see something that looks like this, you need to reinterpret that as the x coordinate is -2 and the y value is -5. So this is telling us, hey, we have a point -2, -5. And it says, okay, we have f of 1 is equal to 4. Again, reinterpret that. That is 1, 4. You have a point 1, 4. So what do we know? And I'm going to go ahead and graph these to make my life a little bit easier. So if I have a normal coordinate plane, a Cartesian plane, if you will, I go -2, -1, 2, 3, 4, 5, and I have a point down here, and 1, 4, 1, 1, 2, 3, 4, and I have a point up here. So this point is right there, this point is up here. That's information that is given by that line right there. We're looking for something following that could be false. So if I'm false, that means most of these are true. Let's see. This is talking about f of c. That's a height. Height is guaranteed by intermediate value theorem. And to do that, you make the little golden rectangle. So the rectangle here any height in between here is guaranteed as long as my x values are between -2 and 1. And it says -2 and 1, so we're satisfying, we're definitely in the right window for the x values, or the c values in this case. It's saying the height is 0. Well, height of 0 is in that rectangle. The height of 5 is not guaranteed, but height of 0 is guaranteed. So this one is a true. It must be true by IVT. We'll say by intermediate value theorem. I don't have to say that, but I'm writing this for the notes just so that you can learn. Okay, what about this one? This is saying f primacy. If it's f prime, that's slope. Slope is given by mean value theorem, and it's saying, hey, the slope is 0. And it's saying, hey, the slope down here is 3. One of these has to be false. You can't have the slope at both these points be a different value. So it's between b and d automatically. Let's go ahead and do that. So mean value theorem, if it's differentiable, it implies, it proves slope. So what is mean value theorem? Mean value theorem is f prime of c is given by f of b minus f of a all over b minus a. And b is going to be the second point. So I'm going to say that, let's call this a and f of a. And this is going to be b comma f of b. Okay, so it says f of b, that's 4. So this is going to be equal to 4 minus, okay, f of a is f of a, which is -5. We have -5, a double negative there happening. And then I get a b down here, which is 4, and then an a, which is a -2. So I have 4 minus a -2. Double negative means we have a positive here. This is going to be 9 over 6, and that simplifies to, is that 9 over 6? That is 9 over 6. That is interesting. I feel like I've made a mistake. Hold on. Let me backtrack here, because 9 over 6 implies to 3 over 2, and none of those are answers. I must have done something wrong. Check how I'm phrasing that. I must have done something wrong because none of those match up. So let's redo this. It is f of b minus f of a. So it's 4 minus -5. That looks good. And then I have a b minus a, b minus a. See, there's our b. Our b is 1. There's my mistake right there. I can catch it. Good job, Mr. Sandell. So 1 minus a -2, which is a 3. And 9 divided by 3 is 3. Okay, now that this is one of the answers, that's one of the, okay, this is the f prime, so it's got to be this answer. This one is therefore true, and this one therefore is false, and the correct answer here is B. But let's move through C and E to see why those are also true. So C is true because this is a height. Height is 3. It says between -2 and 1. Between -2 and 1. So far, so good. It's saying that the height is 3. Well, the height is 1, 2, 3. This height of 3 here is guaranteed. It is inside of this rectangle. So this one is true. You can say this one is true by intermediate value theorem. And this one was true by the mean value theorem that we plugged in. And what about E? E has to be true. So let's go ahead and put the true. Why? This is saying between the closed interval, we don't really care, blah, 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 blah. This is the key part. What does it say? The height at some point is greater than or equal to the height at all points. One height to rule them all. The biggest height is the maximum. So I cross it out and I say, it's saying that there's a maximum. It's saying there is a maximum between -2 and 1. Well, yes, there is by extreme value theorem. Extreme value theorem, which we unlocked because we had these equal to signs down there. We do have extreme value theorem, which states that you have a max and you have a min. And that's what this is saying. You have a max, which is therefore true. All right. So correct answer is B. I over-explained number 16, but I wanted to make sure that you understand. Let's move on to number 17. All right. Number 17, I've got a graph. Let's go ahead and read. Graph of function f. In the future, maybe this will be a graph of f prime, so it is kind of important to know. This is a graph of f. Which of the following statements is false? I'm going to go ahead and underline that because a lot of people say, oh, which one is true? Oh, that one and that one is true, so I can't decide between the two of them. No, all of these are going to be true except for 2. So f of x is continuous at x equals 2. Continuous just means don't pick up your pencil, right? It means you have no holes, gaps, VAs, or endpoints. So if I come up here at 2, right here, did I have to pick up my pencil? Did I pick up my pencil? No, I did not. I have a sharp corner, but I didn't have to pick up my pencil, so this one is true. And therefore, it's not the answer. We're looking for something that's false. It is continuous because we didn't have to pick up our pencil. What about B? It's saying that the limit of f of x as x approaches 2 from both sides, because there's no plus or negative, or positive or negative to the power up there, negative or plus, right? Let's see what we approach. What height do I approach? When I go from the left, and as I approach this barrier at 2, I approach this height of 2. As I approach this barrier from the right, I approach a height also of 2. So the double-sided limit here is actually 2. I'm going to cross this off and say this is just 2. The height is 2. And it's saying, hey, it's equal to the height when I approach 3 from the right. So as I approach 3 from the right, so ignore what happens from the left. I don't care. As I approach 3 from the right, I seem to be getting closer and closer to this height of 2. So that height over here is 2. It's saying, does 2 equal 2? Yes, it does. That is a true statement. Therefore, it's not B. We're looking for a false statement. Let's come down here to see. F of 3 is not defined. That not defined is a curious definition. It just means when we have a line that goes through 3, does it touch the function one time? At least one time, and exactly one time, actually. So I'm going to come down here, and there was an open point here and a closed point down here. Since it passed through this closed point, it touched once and not right there. Because it touched this one spot down here, it is defined, and that's defined at a height of 1. It's asking, what is the height? If we don't have a height, then it's not defined. But this one is defined. So check it out. It's like a double negative. F of 3 is not defined. It is defined. This is a false statement. So this one is actually the answer. False statement. It is defined, and it's defined as a height of 1. What about D? It is not differentiable at 2. Well, there are only 3 things that are not differentiable. There's discontinuities, and there's 4 of those, right? There's holes, gaps, vertical asymptotes, and endpoints. And the second thing is you can have a sharp corner. And the third thing is a vertical tangent. Vertical tangent. Are any of those things going on? And check it out. So at 2, do I have something going on? That's a sharp corner right there. That's a sharp corner. That means I'm not differentiable, which is true. I'm not differentiable because I have a sharp corner. So this one is true. I am not differentiable because I have a sharp corner. All right. I've said that twice, which feels weird. And then finally, f prime of 3. This is saying the slope at 3 does not exist. Well, let me erase some stuff. What is the slope here, guys? I don't know. The slope, there is no slope. Like, the slope over here is clearly like -1. The slope right here is clearly 0. The slope over here is changing. I don't know the slope because I don't even have something that's continuous. I can't tell you what the slope is if I don't even have my pencil being down on the paper. I had to pick up my pencil to go from here to here. So it doesn't exist. I don't have a slope, and this is a true statement. I had to pick up my pencil as a discontinuity, so it's not E. All right, so the correct answer is C, and we've analyzed why all the other letters are incorrect. What about 18? All right, let's read this correctly, though. Which of the following does the limit of f of x as x approaches 4 from both sides, because there's no plus or minus, right, exist? That means I have to approach the same height from the left and the right. Okay, what's the height from the left? It's whatever that height is right there. What's the height from the right? It's whatever height is right there. The left and the right, they're glued together at the same height. Therefore, this one does exist. So go ahead and write a smiley face. It does exist there. As I approach the left and that's from the right and from the left, they seem to be approaching the same height right there. They approach the same height. There's a smiley face for this one. Does this one approach the same height? As I approach from the left, I get this height. But as I approach from the right, I approach this height. These are 2 different heights. These are not glued together at the same height. Therefore, this is a sad face. And the correct answer here is 1 and 2 only. Correct answer is D. Number 19, the slope of the tangent line. Whenever you read slope of the tangent line, let's go ahead and cross it off. Slope of the tangent line, this re-evaluates to derivative. The derivative at x equals 4 of this function, right? This is a new question. It's not a review question like the previous few questions. It's saying, hey, take the slope, take the derivative, and plug in 4. So we need to take the derivative of natural log. So a lot of people say, okay, well, this is really 1 times natural log. That's a good start. And you say, okay, the derivative, the natural log turns into a fraction. This is going to be 1 over x over 2. And you're correct. However, there's a faster way. The faster way is it's the reciprocal of the inner. The reciprocal of the inner is 2 over x. Just flip the inner. Okay, well, that was doubter. Don't forget your dinner. When we multiply our doubter by our dinner, what is dinner? The derivative of x over 2 is the same thing as 1/2 of x, right? These are the same thing. X over 2 is the same thing as 1/2 x. If you don't believe me, then go ahead and multiply x over 1 times 1 over 2. And the derivative of anything x, just x to the power of 1, is the coefficient of x. The derivative of 2x is 2. The derivative of 3x is 3. The derivative of 1/2 x is 1/2. So the derivative of the inner is 1/2. So when I multiply the doubter times the dinner, the 2 and 2 cross cancel, and the answer is going to be 1 over x. And what I should have done right away is plug in 4. I always tell you plug in as soon as possible, but I was just so tempted by that cross canceling. I could not resist. So this x equals 4 is going to come down here, and this is going to be 1 over 4. Correct answer is B, 1 over 4. All right, our final question on the pretest is number 20. And it looks like I'm plugging in 0. Whenever I have a limit, you plug in 0. When I plug in 0, I'm going to get 0 plus 0 divided by 0 over 0. I get the indeterminate form. 0 over 0. Whenever you have 0 over 0, your first choice is to factor, cancel, plug in. Your second choice is probably hotbox. And third choice is El Hopital's rule. But this one is a factor, cancel, plug in because it actually can be factored. Check out the top. If I factor out an x squared, I'm left with a 5x squared plus 8. And again, that word factor out means undistribute. So I'm dividing this term by x squared. I'm dividing this term by x squared. X squared and x squared cancel each other out. That 4 and that 2 are gone, and this 4 changes into a 2. That's why we have the 2 there. We factored out an x squared. What are we going to factor out at the bottom? Another x squared. After I factor out an x squared, I'm left with a 3x squared minus 16. All right, step 1 was to factor. Step 2 is to cancel. Here I go. Cancel the x squareds because they're the same. Got the end of my parentheses over here. And then again, we'll plug in the 0 into this x and plug in 0 into this x over here. That's going to go away. That's going to go away. I have an 8 over a negative 16, 8 over a negative 16, which is a negative 1 over 2. The correct answer is A. All right, and that was a review from Unit 1. All right, and I have now finished part 2 of 2 for my AP Calculus AB Pretest 2 video solutions. Thanks for watching.